And when we talk about properties, there are two main properties that we have to study, the physical properties and the chemical properties. So starting with the physical properties, please write the heading. Physical properties. No, whenever see this physical properties will be, Achha, guys, can you please turn your cameras on? Also, this physical property, there are three components that is always present in each and every chapter. The method of preparation is always there in every chapter. Then we have physical properties, and then we have chemical properties. Okay, so these three components are always present in every chapter. So what are the physical properties that we are generally going to study? The physical properties that we are going to study is melting point, boiling point, and solubility. These are the three main physical properties that we are going to study. Okay. Also, one more thing is dipole moment, and dipole moment is going to decide whether something is having high boiling point or low boiling point. Okay. So in physical properties, first of all, write the boiling point. Take a boiling point. Take a boiling point. Now, the boiling point of haloalkane is, you can write here, haloalkanes are more polar than hydrocarbons. Hence, their boiling point is greater than the parent hydrocarbon. Okay. So if you have any haloalkane, that is Rx, so Rx is going to be more polar. That means it will be having delta negative and delta positive charges. And that is why, since it is more polar, there will be more force of attraction between two molecules. It will be having greater boiling point than any any alkanes. This is haloalkane, and this is alkane. Now, if we have same halogen atom, but the difference is present in the number of carbon atom, then boiling point is directly proportional to number of carbon atoms. So boiling point, it is directly proportional to number of carbons. Okay. So for example, if you have CH3X versus CH3CH2X, please remember this X is halogen, and the halogen, if it is fluorine, all will be, the comparison will be only with fluorines. Okay. CH3 CH2 whole twice X, and if you have CH3 CH2 whole thrice X. Okay. So in this case, if I talk about the boiling point, then the larger the number of carbon atoms, larger is the boiling point, because as the molar mass increases, the van der Waals forces will also increase, and the boiling point will also increase. Now, this is when you are having same halogen atom. Now, if you have the alkyl group same, then please see boiling point, it is directly proportional to the molar mass of X. Now, in this examples, what will be changing? The halogen atom will be changing. So if I compare RF, RCl, RBr, and Ri, then alkyl iodide is having more boiling point than alkyl bromide, and then chloride, and then fluoride. Okay. Example would be something like this. You have fluoroethane, it will be having lower boiling point than chloroethane, it will be having lower boiling point than bromoethane, and it will be having lower boiling point than iodoethane. And the next concept is important, that boiling point, it is inversely proportional to branching. is inversely proportional to branching. That means as the branches increases, the boiling point will become lower. Okay. So for example, I will explain why this happens also, but पहले इसको समझ लीजिए. What is the trend here? So we are having 4 carbon atoms and a Br. This is C4H9Br. Okay. Then we have one branch like this. Then you can have another branch like this. So all of these are 1, 2, 3, 4 carbon atoms, C4H9Br. Here also one carbon atom, 2, 3, 4. And 4 carbon atom, C4H9Br. But if do you guys know what is dipole moment? Can I get a yes or no, sir? Dipole moment from physics. Opposite charges with a separation. Okay, tell me. Yusuf, Arsalan, Krishna and Mir.
Yes, sir.
है ना डाइपोल मोमेंट पता है आप लोगों को पॉजिटिव और नेगेटिव चार्ज के बीच में जो सेपरेशन होता है ना नाउ व्हाट इज द म्यू इज दिस इक्वल टू if the charges is plus q and minus q, what is the formula? Mu is equal to, and the distance is d.
2qd.
Mu is equal to 2qd or qd only?
Oh, in physics we are learning the d as distance from charge and center. So but it is charge into distance of separation.
है ना charge into distance of, if I am taking this charge into distance of separation. So if the d is higher, then the dipole moment will also be higher. Correct, guys?
Yes, sir.
ठीक है अब ध्यान से देखिएगा जरा यहाँ पे we are having, see, bromine is what? Electronegative elements, it will be having delta negative, and due to inductive effect this will get delta positive, this will get small positive charge, this will also get very little positive charge, this will also get very little positive charge. So overall if I look at the molecule, there is a dipole. Okay, this molecule, it is a polar molecule, and if I see here, if this whole thing is a molecule, then here we will be having the negative charge, and here we'll be having the some positive charges, right? So you compare the distance here. Now if I look at here, this is my compound. The delta negative charge is here, and the delta positive charge is here. Look at the distance, delta negative and delta positive. Now this molecule is like this, it's almost spherical here. So it is delta negative, delta positive here, and delta negative here. So as you can see, as the branching is increasing, what is happening? The distance of separation between the charges is decreasing and the dipole moment decreases. And when the dipole moment decreases, the force of attraction, देखिए positive negative में ही attraction होगा ना. For example, if you see this is a compound, okay. Here you are having delta negative, here you are having delta positive. और दूसरा compound यहाँ पे. So these are what? Two molecules. इसका delta negative यहाँ पे, इसका delta positive यहाँ पे. When I am talking about boiling points, I am talking about the forces of attraction between two different molecules. एक मॉलिक्यूल के अंदर कार्बन और ब्रोमीन का बॉन्ड कितना अच्छा, उससे कुछ लेना देना नहीं. We don't even have to see that in a compound what type of bonding is there. We don't have to see that. We have to see what kind of force of attraction between two molecules, because when you are boiling, what is happening? It is going from liquid state to vapor phase. When it is going from liquid to vapor, molecules are getting separated. Atoms के बीच में कुछ नहीं हो रहा है. So if you see, if I am having higher dipole moment, then there will be more force of attraction between these two molecules, and a delta positive and delta negative will attract each other. Okay, so the molecular interaction will be higher if you are having higher dipole. As you can see, the distance is getting lower and lower. The dipole moment will also get lower, and the force of attraction will also lower down. That is why I say boiling point, it is inversely proportional to branching. जैसे branching increase करेगी, force of attraction would decrease. When the force of attraction would decrease, you would require lower temperature to boil the molecule. है ना? That is why boiling point is inversely proportional to branching. इस केस में सबसे ज्यादा ब्रांचिंग यहाँ पे, तो इसकी boiling point सबसे कम. This will have the highest boiling point, then followed by this one, and then this one. ठीक है? So please raise your hand once you're done writing this. Waiting for Yusuf, Arslan, and me. Okay, fine. Everyone is done. See here next. Now, when we talk about haloarenes, no? When you talk about haloarenes, in that case, you have to look at the structures. Okay. So basically, in di-substituted benzenes, वहां पे कंपैरिजन आप मतलब जनरली ये नहीं पूछा जाता, बट स्टिल दिस रिजल्ट इज इंपॉर्टेंट. इट इज समवेयर समटाइम्स आस्क्ड इन क्वेश्चंस, है ना. फॉर एग्जांपल यू हैव O chloro benzene, and then you have chlorine and chlorine in the meta position. So this is M dichlorobenzene, meta dichlorobenzene, and then you have chlorine and chlorine, that is para dichlorobenzene. Now if I look at the dipole moments here, please see here guys, ध्यान से देखिएगा यहाँ पे dipole moment when we are talking about, then here we have to look that where is the polarity, है ना, delta negative किधर है, delta positive किधर है. So chlorine, since it is more electronegative element, it will be having delta negative charge. So delta negative, delta negative, delta negative, delta negative, here delta negative and delta negative, right? Now, as you can see, the dipole moment from positive to negative jata hai, so obviously we are having two dipole moment here because of this particular bond like this, and there is one more dipole moment like this. If I look here, there is a dipole moment like this, and there's a dipole moment like this. Now here we have a dipole moment like this and like this. So when I talk about the para isomer, okay, all of these are, they are having same molecular formula, but the difference is in their position. So this is a ortho isomer, ortho. This is meta, and this is para. So if you look at the para isomer, you can completely see that the dipoles are they are directed in the opposite directions. So you can see that this dipole is cancelling the downward dipole. So here the mu net will be equal to 0, and it will be non-polar substance. इसमें polarity बिल्कुल होगी ही नहीं, ठीक है. If you look at the meta position, please see in the meta position, this is upward, और ये एक particular angle में है, ठीक है. Now this angle, इसका अगर component निकालें आप, तो एक आपको rightward component निकलेगा और एक आपको downward component निकलेगा. Correct है guys? Yes or no? Please tell me. I hope you guys remember some vectors, right? If you want to see the components up or sin और cos theta से निकलता है. You guys remember this? Yes or no? Please tell me guys. थोड़ा सा भी याद है?
Yes,
I think it is resolution of a vector, right? Resolution of a vector, है ना?
Yes.
हाँ. So if you resolve it, then you will get a in the right side and then in the downward side. So you can see there is some cancellation. I will not talk about the values here, but you can see upward में थोड़ा है, and obviously here it will not be as the dipole moment which is downward, it will not be as strong as the upward because it is one of the components. So I can say there is some cancellation here. Here there are complete cancellation of dipole. There is some cancellation here. But if I look in this particular dipole, so this is upward, and for this I have to make some component. So there will be an upward component, as you can see in the y-axis, and there will be a rightward component. है ना? अब यहाँ पे there is no cancellation. Can you see that? Upward तो add कर जाएगा, और right वाला का तो direction ही अलग है. So you will get a what I can say resultant vector निकलेगा आपको बीच में इस तरह से, है ना? It will be the resultant of this upward, and this rightward. Correct है? Now here you are not going to have any cancellation. Here there is some cancellation, here there is complete cancellation. So from here you can say what? अगर हम unit की बात करें, so unit में इसका 0 है, सबसे ज्यादा किसका होगा? Ortho का, and then meta, and then para. And similar is the boiling point. Boiling point, but please remember boiling point. Boiling point of, in general I can say, ortho and meta isomers is greater than that of para. Boiling point of ortho and meta में बहुत ज्यादा फर्क नहीं होता है, but still ortho is greater than meta and then para. But ortho and meta का, if you are going to take the boiling point and compare it with the boiling point of para, there is a large difference. So we can say boiling point of O and M isomer of dichlorobenzene is much higher than its P isomer, para isomer. ठीक है? This is one of the result that you have to remember, है ना? and this result will be used in a question. Okay, and the question will not be about this particular result. It will be about something else that we are going to just learn right now. Okay, please write this down and raise your hand once you're done. Raise your hand once you're done. Please raise your hand once you're done writing. Yusuf, just waiting for you now. Okay, done. ठीक. Now, right next, melting point. Okay, melting point. So please understand one point. The basic difference between if I talk about boiling point and melting point is that in boiling point only there is only one factor that we have to look. It is the interaction, and that is basically can be decided by the polarity. If something is more polar, it will be having higher boiling point. If something is less polar, it will be having lower boiling point. But when we look at melting point, there are two main factors. The first one is obviously intermolecular force of attraction. Intermolecular force of attraction. Like what kind of attraction is there? That means polar or non-polar. But the second and quite important sometimes is the packing. Packing का मतलब ये है that solid जो होता है ना, the solid is a lattice. I mean, in that the atoms are fitted. They are not loose. They are held in a position. So you have to see if the packing is symmetric or unsymmetric. If the packing is symmetric, that means the atoms are held and there is very less space between them. Not because of the force of attraction. ठीक है, इस बात को समझिए. When you are melting something, what you are creating more space between different molecules. When we are having a liquid molecule, then the molecules they don't have their fixed space. They don't have their fixed place, right? But when we are going from solid to liquid, in solid, each and every molecule it is having their fixed space, fixed position. And if the molecule is symmetric, then the packing will be effective. And they will be packed in such a manner that the space between two molecules is very less. In packing, you have to see whether it is symmetric or unsymmetric. Unsymmetric. Here, basically, what you have to see in intermolecular force of attraction is polarity. The polarity is greater or lower. In packing, you have to see the symmetry. Now, the main question that you will see in this part is regarding the dichlorobenzenes itself that we have just discussed. Please see here, guys. I'm going to look at the same ortho, meta, and para. This is ortho isomer. Then we have the meta isomer like this. And then we have the para isomer like this. Now I need an answer. Which one is most symmetric? Tell me, guys. Which one is A, B, C, D? A, B, C में बताइए. A, B, C में. Which one is most symmetric in the chat? chat in the chat, please. Send the answer to Salim in the chat. Yusuf, आप कैमरे में बता सकते हैं 1, 2 और 3 which is most symmetric. Yusuf, you have said in the chat. ठीक है. Arsalan and Mir, I'm waiting for your answers. Arsalan, are you not there today? What happened? You're not speaking any word.
Yes, sir, I'm there. I'm just a bit sick today, sir.
Acha. So, which is most symmetric, Arsalan? Any idea? ABC, Mir, any idea? No. I think if I say the answer, you would be obviously agreeing with me that C is the most symmetric. And only because of symmetry, what happens? The dichlorobenzene, the para-dichlorobenzene, they can fit in a lattice very easily. Okay, you can see this happening. Can you see this? Now, obviously, I will remove the chlorine, but I'm just showing the importance of para position. Okay? I mean, I hope you understand that chlorine as a Cl करके कोई atom नहीं होगा reality में. That if you zoom down into para-dichlorobenzene, which will be in solid state, white solid होगा, उसमें अगर आप zoom down करेंगे तो आपको ऐसा कोई Cl लिखा हुआ atom तो नहीं दिखेगा ना. You will just see spares and charges and negative charge and positive charge because of electron and proton. So basically, this is the structure that you will be seeing. है ना? If I move one more, guys. Even this, you can see how effective the packing is. Can you see that? And this is with my untrained hands. And the lines are not equal, right? But you can see how close these atoms, how close these molecules are actually. Now, no matter how much dipole moment this orthoisomer is having, it is in such a weird and unsymmetric. It is such a weird and unsymmetric type of geometry, or I can say shape, that it can never fit as we are fitting the para isomer. So you can see which will be the most difficult to break. Tell me, guys, A, B, or C. Which will be C will be most difficult to break because their atoms and the molecules are very close to each other. That is why what is now happening, the para isomer is having the highest melting point. Para isomer of dichlorobenzene has higher melting point than its ortho and meta isomers. Why? Due to symmetric structure. Due to symmetric structure, it can easily fit in lattice. So, due to higher packing efficiency, large energy is required to melt. ठीक है, अब ध्यान दीजिएगा जरा. The words that are heavily important here is first of all the symmetric structure, है ना? Due to higher packing efficiency. ठीक है, so these words are very important. मतलब सबसे ज्यादा important is particular if they are asking why, the question that usually they give is why is the melting point of p-dichlorobenzene higher than its ortho and meta isomers? You just answer due to symmetric structure. I mean, ये पूरा लिखने की जरूरत नहीं है because you are having question. You just need to start from due to symmetric structure. It can easily fit into lattice, and due to higher cracking efficiency, large energy is required to melt. ठीक है? So symmetric structure is very important, and this particular answer was as it is given by CBSE. ठीक है? So it is not even from NCERT, this is from CBSE. क्वेश्चन भी है साथ में सवाल आंसर भी. Now, very long ago, in 2012 or 2011 sometime, they asked these two questions एक साथ, एक ही सवाल में दोनों था. They asked like this: the para-dichlorobenzene has higher boiling point than its para-dichlorobenzene has lower boiling point than its ortho and meta isomer, but it has higher melting point than its ortho and meta isomer. Why? So वहां पे आपको you have to give the answer for both things. When they are saying that the para isomer it is having lower boiling point than ortho and meta, ना ortho meta का क्या होता है, higher होता है para से, para का क्या कम हो गया, तो para is having lower boiling point than its ortho and meta isomer is because of the dipole. ठीक है? Because para isomer is non-polar. ये है ना non-polar. It is non-polar. You will write this answer. Then you will write. Then they ask like this. But the para isomer of dichlorobenzene has higher melting point. तो उसके बाद फिर आपको ये आंसर लिखना पड़ेगा. Because of symmetric structure. The boiling point is lower because of non-polarity, and the melting point is higher because of symmetric structure. That's the thing that you have to write. Really raise your hand if you have done with the melting point part. Raise your hand if you're done with the melting point part. Okay, everyone is done. ठीक है, अब जो नेक्स्ट है हमारे पास दैट इज डाइपोल मोमेंट. ना ईच एंड एवरी ना सारे से ही सवाल आ सकता है. ठीक है, तो देयर इज नो फिजिकल प्रॉपर्टी व्हिच इज नॉट वेरी इंपॉर्टेंट. सारे इंपॉर्टेंट सब में मतलब बिल्कुल वाई टाइप के सवाल है. यू विल गेट द मोस्ट नंबर ऑफ वाई क्वेश्चंस फ्रॉम दिस चैप्टर इटसेल्फ, हैलोअल्केन हैलोअरीन. ठीक है, सो प्लीज सारी चीजों को ध्यान में रखिएगा. डोंट गिव लेस इंपॉर्टेंस टू एनीथिंग. मेल्टिंग पॉइंट, देन वी आर हैविंग डाइपोल मोमेंट. डाइपोल मोमेंट. Now, so since you all know what is dipole moment, it is mu, that is product of the charge and the separation between the charges, q into d. दो चीजों पर डिपेंड करता है, the charge and the dipole moment. Now there is first thing that we have to compare is haloalkene versus haloarene. Now, if I look at haloalkane and haloene, so a good comparison will be with cyclohexane, or fluorocyclohexane, or chloro, or any halogen, halogen, and same number of carbon atom, but it's the haloarene, which is chlorobenzene or halobenzene, anything else. Okay. Now, as you can see, the polarity will be almost same. That this is having delta negative, this is having delta negative. Now, what are the differences that we are going to look? The differences that you are going to face is this carbon atom here, it is sp3 hybridized. But this carbon atom here, this is sp2 hybridized. So sp3 is less electronegative, sp2 is more electronegative. That's the first difference. Next, the bond that we are having, the CX bond here, this CX bond that we are having, this is single bond, completely single bond, only single bond. This is single bond. But if you look at this particular bond, this is having resonance, and that is why it is partial double bond. It is partial double bond. Now, when you look at both of these differences and then conclude, you can say that, see, since sp3 is less electronegative, ध्यान से सुनिएगा ना, थोड़ा सा ट्रिकी है, तो इस वजह से थोड़ा सुन लीजिए. Guys, please listen. Please listen. Here the CX bond, and if I look at the atom C and X, the carbon atom it is sp3. And here if I look at carbon and halogen bond, the carbon atom here it is sp2. And if you compare the electronegativity, then the sp2 is more electronegative than sp3. So where would be the difference in electronegativity higher? Delta En कहाँ पे higher होगा? 1 में या 2 में? Write the answer in the chat. थोड़ा सा ट्रिकी इस वजह से हम पूछना चाह रहे हैं आप that you apply some of your mind to it. Where will be the electronegativity difference higher? Where there will be larger electronegativity difference, in the first case or the second case? Okay, Yusuf. What about others? Arslan, Krishnapriya, and Meer. Answer quickly, guys. Krishnapriya, Arslan, and Meer. Okay. I will give you 10 more seconds. 10, 9, 8, 6, 5. जल्दी जल्दी है ना, जल्दी. 4. Arslan and Krishnapriya waiting for your answers. 3, 2, and 1. Okay, fine. Only Arslan, Mir, and we have answered SP3. Yeah, Mir, sometimes it would feel that where there is more electronegativity, there will be more electronegative difference, but that is not true because आप समझिए, देखिए हम numbers देते हैं, ठीक है ना? I'm giving numbers. So between carbon and halogen, which is more electronegative? Halogen. तो halogen की एक number दे दीजिए आप 10, 10. sp3 को you get the number 5, ठीक है? Now halogen still here it will be 10. And we know that sp2 is more electronegative, तो इसको 8 नंबर दे दें. Now where is the difference larger? नंबरिंग रेटिंग दिया जा रहा है इलेक्ट्रोनेगेटिविटी के हिसाब से, ठीक है? सो हाइड्रोजन इज मोर इलेक्ट्रोनेगेटिव ना, सबसे कार्बन से तो ज्यादा ही है. नो मैटर व्हाट काइंड ऑफ कार्बन वी आर हैविंग, हाइड्रोजन विल बी मोस्ट इलेक्ट्रोनेगेटिव. तो कार्बन इज गेटिंग डिफरेंट नंबर बट हाइड्रोजन इज सेम XX, तो उसको 10 10 दे दिया गया. sp3 कार्बन इज लेस इलेक्ट्रोनेगेटिव, तो उसको 5 दिया. sp2 इज मोर इलेक्ट्रोनेगेटिव, तो उसको 8 दिया. तो यू कैन सी द डिफरेंस कहां पे ज्यादा है. यहाँ पे 5 का डिफरेंस है और यहाँ पे 2 का डिफरेंस है. That is why the electronegativity difference will be higher in the first case than in second case. I hope Mir this is clear. Okay, I hope this is clear now, that which will be having more electronegative difference. Now, if there is more electronegativity difference, that means there will be larger charge, delta positive and delta negative charges जो होंगे, their value will be higher. Sir, I sent you the answer. Krishna Priya, answer आपका?
I sent you the
Oh,
answers.
yeah. Sorry. I missed that. Yeah, first one, correct. Okay. So electronegativity difference is higher in the first case. So the charges will also be higher. तो आपने देख लिया, because of electronegativity difference, what we can say, the Q is higher. Q की अगर हम बात करें ना, charge कहाँ पे higher है? It is greater in first and then second. Now let us see about the bond. If you look at the bond here, this is completely single bond and this is partial double bond. And partial double bond is shorter. Single bond is longer. So if I look at the distance, then in distance also I can say that the distance between the positive and negative charge is greater in one than in second. From here we can easily conclude the haloalkane is more polar than haloarene. Okay, so you can write haloalkane is more polar than haloarene because sp3 carbon is less electronegative than sp2 carbon and haloarene has partial double bond. Okay, please write this down. Raise your hand once you're done. Okay, understand. Now there is a question in NCERT regarding the dipole moment, तो उसको भी discuss कर लेते हैं. Now all of these things ना, these are conceptual trainings for the further next chapters. वो ध्यान रखिएगा आप लोग. Okay, whatever we are learning in this chapter ना, it will be applied, and the concept that we are using regarding the dipole moments, that cancellation, no cancellation, resolution of a dipole. So you have to remember these things. See here, guys. There is a question in your NCERT. It asks, I think it is 10.4, 10th chapter, the fourth question. Which one of the following has highest dipole? Has highest dipole. So the first option is CH2Cl2. Second option is CHCl3. Third option is CCl4. ठीक है. Now अगर हम यहाँ पे ध्यान दें, let us make these compounds. So carbon will be a tetrahedral carbon. So with two bonds in the plane, one bond outside the plane, and the other bond will be inside the plane. Now this will be the same, the geometry will be same in all of these. So I'm just copy pasting this. The difference will be only in the placement of hydrogen and carbons, the number of carbons and hydrogen. Number of chlorines and hydrogen, not carbon and hydrogen. Here we are having two hydrogens and two chlorines. So I will put the hydrogens like this, and I will put chlorine and chlorine like this. Okay. And in this case, we are having three chlorine atoms. So एक hydrogen का ऊपर दिया, इधर chlorine, and इधर chlorine. And here we are having all of them are chlorine. So chlorine, 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 and chlorine. ठीक है. अब थोड़ा यहाँ पे ध्यान दीजिएगा आप लोग. Let us start with the polarity and let's look at the dipole moments. So since chlorine is more electronegative, there will be dipole moment. That means negative charge will be in the chlorine atom like this: delta negative, delta negative, delta negative. Now there will be four dipole moments I can make. So you can assume that this is one dipole moment, right? This is another dipole moment, that is the bond itself. This is a dipole moment that is coming outside the screen. There's a dipole moment which is going inside the screen. Okay. Now we have to resolve these dipoles. So I will take the two which are, okay, this is on the plane. And if I resolve these two, and if I take the resultant here, then the resultant would look something like this. In between the two, and this will be in the plane. Correct, guys? Yes or no, please tell me. I hope this makes sense. This is the resultant dipole. क्या ख्याल है? Resultant dipole, no problem ना? Yes sir, no sir, कुछ बोल आवाज आ जाएगी please. थोड़ा इत्मीनान हो जाएगा हमें. Yes sir, no sir, है ना? Makes sense. Okay. Now if I talk about the dipole which will be existing for the outside the plane and inside the plane, ठीक है? तो ध्यान दीजिए, थोड़ा सा सोचिएगा इस बारे में. Outside the plane and inside the plane there are two dipole moments. One is outside the plane and the other is inside the plane. So the resultant will be in between outside plane or inside plane के बीच में क्या आएगा? On the plane. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
Completely makes sense, na? And the direction, if I show, it will be just the opposite. Like this. Can you see that? Correct है guys?
Yes,
अरे
sir.
अच्छा, अब आपको क्या चीज ये दिख रही है? That these two dipoles, both of them are on the plane and they are in the opposite direction. So I can confidently say that the mu net here will be equal to 0. क्या ख्याल है guys? Correct है? Tell me, Yusuf, Arsalan, Krishnapriya, and Mir.
Yes,
Yes,
sir.
sir.
Okay, ठीक है. Now let us look at the next case. Here we are. Anything, Krishnapriya? Any doubt?
No, sir.
No. So we are having delta negative, and delta negative. I'm ignoring the hydrogen because hydrogen is not electronegative. So basically, the most dipole that we'll be having will be because of these three only. So we are having this dipole moment ना, इसका हम लेके I am making the resolution. ठीक है, तो एक तो लोअर जाएगा नीचे की तरफ और एक उधर जाएगा. ठीक है. Now here also there will be one lower and it will be only lower. एक नीचे की तरफ आएगा and one will be pointing towards the direction outside the screen. अब वो स्क्रीन से बाहर हम तो बना नहीं सकते. ठीक है, बट आई होप यू कैन इमेजिन. इसको हम ऐसे डार्क कर दे रहे हैं. तो दिस विल बी वन ऑफ द कंपोनेंट. एक कंपोनेंट नीचे की तरफ है और एक कंपोनेंट इट इज कमिंग टुवर्ड्स यू, है ना, फ्रॉम द स्क्रीन. एंड हियर आल्सो यू विल हैव वन कंपोनेंट व्हिच इज बिलो and the other component, rather I should say one component will be in this direction, है ना, and the other component will be going inside the screen. Can you imagine that? Tell me guys.
Yes, sir.
ठीक है, inside the screen. अब थोड़ा अगर इसको आप समझ लें यहाँ पे, तो there is some cancellation happening. दिख रहा है आपको some cancellation?
Yes, sir.
ठीक है, तो इसको अब ऐसे ही रखते हैं, some cancellation. The unit will be present. Unit is not less is equal to 0. It is greater than 0, but there is some cancellation happening. ठीक है. Now if I look at the last one, in this case you see that there is one outside the plane. ये वाला dipole है. One inside the plane, this dipole. So in this case there will be only one existent dipole which will be in the plane and in this direction. जो कि हम लोगों ने यहाँ पे ये वाला बनाया था. Similar to that one. And there will be no cancellation as you can see. क्या ख्याल है guys?
Right, sir.
Right, so no cancellation. And when there is no cancellation, this will be having the highest dipole moment, then the CHCl3 and then the CCl4. I hope all of you understand. See, in chemistry, you don't have to remember too many values. Okay? Either they will give you too many values, they just want you to apply your concepts. Okay? You have to apply your logic here. That okay, fine, there will be some cancellation, there will be no cancellation, and एक जगह पूरा cancellation हो जा रहा है. ठीक है? Very basic logics, but you have to remember these things how you have to apply, है ना? देखिए, हर चीज को मतलब समझने की चीज तो है ये, थोड़ा सा रटने वाला भी पार्ट है, तो इसको याद कर लीजिएगा. ठीक है. आप अगर प्रोसेस को भूल गए, दैट यू हैव टू टेक, इसमें भी एक देयर इज अ ट्रिक ऑफ हैंड ना, कि अगर एग्जाम में ये दोनों को ले लिया, इफ यू आर टेकिंग वन इन द प्लेन एंड वन इनसाइड द प्लेन, इट विल बी वेरी डिफिकल्ट फॉर यू गाइस टू मेक द रिजल्टेंट या फिर रिजल्टेंट वेक्टर. ठीक है. सो यू हैव टू रिमेंबर, यू हैव टू मेमोराइज व्हाट आर द वेक्टर्स यू आर गोइंग टू टेक और किसका रिजल्टेंट लेना है. ठीक है. तो प्लीज रिमेंबर दैट and then you can apply your logics, that you have to take the vectors which is on the plane and on the plane, or एक लेना outside the plane or inside the plane वाला. यहाँ पे you have to take the individual vectors, then resolve it, and then you can see that there is some cancellation. And here at last you will see there is no cancellation. Write this down, raise your hand when you are done. Just waiting for me now. Okay, fine. Everyone is done. The last in physical properties is the solubility. Is right, haloalkanes are polar, but still partially soluble that is immiscible in water. Because the interaction between Rx, that is haloalkane, and water is not strong enough to break the interaction between water molecules. To break the interaction between water molecules. अच्छा एक काम कीजिएगा, टू ब्रेक द, एक और लाइन यहाँ पे आई थिंक इट विल बी एन एडिशन, टू ब्रेक द हाइड्रोजन बॉन्डिंग, the hydrogen bond interaction, H bond interaction between water molecules. So this will add more points to your answer. It's not enough to break the hydrogen bond interaction between the water molecules. Okay, this is very simple because haloalkanes they cannot form hydrogen bond. That is why they are not soluble in water. Okay. Next, haloalkane, that means Rx, are organic solvents. Organic solvents are generally non-polar, so they can easily dissolve Rx. Rx is haloalkane. Raise your hand once you're done. Okay. Think everyone is done. Yusuf got disconnected and he's not back. Okay. So this is all about the physical properties. Next, we are going to look at chemical properties. Chemical properties of haloalkane. Next, after that, chemical properties of haloalkane, then we will look at the chemical properties of haloarene also. Okay, so the main reactions that haloalkanes show, there are three main reactions: nucleophilic substitution, elimination, and reaction with metal. Okay, so please write haloalkanes show primarily three types of reactions. Not three reaction, okay, three types of reactions. The first one is nucleophilic substitution. The second one is elimination reaction, elimination. Third is reaction with metals. First of all, we will look at nucleophilic substitution reaction. After that, the elimination reaction, and then reaction with metals. Okay, so please write the heading. It's a nucleophilic substitution, right? Nucleophilic substitution reaction. Okay, nucleophilic substitution reaction. So in this reaction, basically what will happen? Reactant में तो आपके पास होगा haloalkane. Then there will be some nucleophile, and nucleophile will generally contain a lone pair. Negative charge can be present and can not be also present, but lone pair जरूर होगा उसमें. And basically what would happen? The nucleophile will replace the halogen as X negative. ठीक है? Nucleophile will remove the hydrogen as X negative. तो ये आपका Nu जो है, this is nucleophile. ठीक है? And this R is the alkyl group, and this X negative, it is known as the leaving group. ठीक है? अब nucleophile, leaving group, and if I talk about the R is alkyl group. The most important, there are few important things that you have to learn in this nucleophilic substitution reaction. एक तो जो reaction से actually उसको याद करना पड़ेगा आपको, and then the terms are there ना कि जो this nucleophile which is the incoming this is what electron rich species, it is nucleophile. ठीक है? फिर जो बाहर निकल रहा है, the X, that is known as the leaving group. So these are the terms that you have to remember. Another thing that you have to remember is the factors that are going to affect the nucleophilic substitution reaction. और उसके बाद जो मेन चीज है आपका the types of nucleophilic substitution. अच्छा, nucleophilic substitution को ना SN बोलते हैं, SN. ठीक है? अब यहाँ पे अगर आप ध्यान दें तो दो चीज हो रही है. Whenever there is a reaction happening, ना, there will be two things occurring: bond breaking and bond formation. So can you see that what is happening in nucleophilic substitution reaction? You can see that the RX bond is getting broken. है ना? Carbon halogen bond, the carbon halogen bond, CX bond, breaks, and carbon nucleophile bond forms. Can all of you see this, guys? Arsalan, Krishna Priya, and Meet. I hope you're not having any problem here. Correct, guys?
Yes.
ठीक. यही समझिए, like there are these two things are happening. Now, one way of happening of this reaction, occurring of this reaction, is that both these steps can happen simultaneously, or both the step it happens in single step. ठीक है? तो यहाँ से सुनिएगा. Don't write anything. I'm just introducing you to something. इसके बारे में we'll be learning in detail, so you don't have to write it down. Just try to listen and understand each and every point right now. तो लिखने में आप लोग को आसानी होगी. ठीक है? You don't have to write here. बहुत ही अच्छे से लिखाएंगे हम. अभी जो लिखा रहे हैं इसको समझने के लिए सिर्फ देखिए. ठीक है ना? Just try to understand here. Now the reaction SN, अगर हम SN की बात करें तो SN दो तरीके से हो सकता है. Like both of these two things, है ना? These two steps एक बार में हो जाए या फिर two steps में हो जाए. SN can occur in single step, or it can occur in two steps. If it is occurring in single step, then what is going to happen? Please see here, guys. You have a nucleophile, and then you have the RX. The X here is more electronegative. That is why it will be pulling electron and having delta negative charge. The R will be having delta positive charge. The nucleophile, since it is electron rich with a negative charge, it will attack on which delta positive or delta negative? Tell me, guys, कहाँ attack करना चाहेगा? The nucleophile will attack which is electron rich, which is negatively charged. It will attack where? Delta positive or delta negative?
Delta positive.
Delta positive. Very good. है ना? So it will attack on the delta positive, and as it attacks, this bond will be getting broken. So this attack is showing the formation of bond, and this electron movement, it is showing the breaking of bond. And what you will see that there is a nucleophile attached to the alkyl group, and the X has leaving because it gets both the electron from the bond. So this is happening in single step. Now, if the same thing happens in two steps, then what are the steps that would be occurring? In the first step, the alkyl and the halogen, this bond would break, because carbon cannot form more than 4 bonds ना, तो उसको पहले bond तोड़ना पड़ेगा, then only it can have a new bond, and X negative will be there. In the second step, what would happen? The nucleophile, which is having lone pair and electron, which is electron rich, having lone pair and negative charge, and R positive would be there, and the nucleophile will attack on the R positive. So you will get RNE. Okay. So overall, you can see that R and R can cancel here, so you will have X negative overall reaction. Okay. Now, let us see the first one. In single step, if this is happening, then if I talk about the rate of reaction, how fast this reaction can occur, then we can say that jitni, like the number of times nucleophile is attacking the haloalkane, the number of times nucleophile is what? The nucleophile is colliding with haloalkane. That many times the reaction would occur. Can I say that? Yes or no, please tell me. Aslan, Krishna, Priya, and Meet.
Yes,
If nucleophile and alkyl group are colliding frequently, if they're colliding frequently, then frequently this reaction would occur. And if the rate of collision is very high, that means they're colliding very frequently with respect to time, then what we can say that this reaction will be higher. So how can we make these two collide frequently? We can increase their concentration. या तो आप nucleophile concentration increase कर दीजिए, or you can also increase the concentration of alkyl group. So in this case, I can say that the rate will be directly proportional to nucleophile as well as the alkyl group. Now, if I look at this particular in 2 steps happening, now we have to see which step is more important. Which step is going to determine the rate? Now the rate determining step is the slowest step. वो हम आपको बता देते हैं किस तरीके से. Let us say, for example, I have a t-shirt, I have a shirt, and I have a jeans. ठीक है? T-shirt it dries in 5 minutes. This shirt it dries in 10 minutes, and jeans takes 15 minutes. So what is the total time taken for drying all of these 3 articles? Tell me in the chat, please. What time would be taken if I want to dry all of these 3? The total time taken would be how much? Send your answer in the chat. What would be the total time taken to dry the t-shirt, shirt, and jeans? Okay, Krishna Priya, I'm waiting for others. Aslan and Mir. This is a simple question, no? You can answer quickly. Okay, 10 more seconds, guys. Aslan and Mir. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Oh, okay, fine. You did not give me any answer, Aslan and Meera. I think you guys are not here then. But this was very simple. Hai na? In single step, no, Arslan, you are not listening. You're not listening, I think, Arslan. I'm asking how much time it will be taking. ठीक है, खैर, कोई बात नहीं. Please watch the recording. What can I say now? So it would take 15 minutes only, because in these 15 minutes, there are 5 minutes in which the t-shirt will also dry up, and 10 minutes में shirt हो जाएगा. And the next 5 minutes, the jeans would take, right? So here we can say, if I want to dry something fastly, if I want to make this whole process fast, I have to increase the speed of drying for this jeans part. That means the article, the cloth which is taking the longest time to dry, that means the slowest step, that is going to determine my rate. That is going to determine the rate. So that is why I say that the rate determining step, RDS, is slowest step. Rate determining step is slowest step. ठीक है? अब यहाँ पे देखना है which is slowest step. If I look at the first step, there is bond breaking. In order to break a bond, we have to give energy. In the second step, you can see positive and negative charges are there, they're combining. So you don't have to give any energy to combine positive and negative charges, right? They will automatically, they will come together and they will make a bond. But you will be requiring some kind of energy for the first step. So we can say that first step is slowest, and out of the two, which is slowest? The first step. Therefore, this step will only determine the rate of reaction. That means I can say that rate will be directly proportional only to the concentration of the haloalkane. Now, from here, the name comes. The nucleophilic substitution reaction, in which the rate is determined by two different molecules. Two molecules, that means bimolecular reaction. This is a SN, which is bimolecular. And here the rate is determined by only one molecule. That is why it is unimolecular. So there are two types of SN: bimolecular nucleophilic substitution and unimolecular nucleophilic substitution. इसको बोलते हैं SN2 and this is known as SN1. Unimolecular nucleophilic substitution to bimolecular nucleophilic substitution. Is this clear, guys? Yes or no? Please tell me.
Yes, sir.
What about others? Arsalan and Arsalan, तो पता नहीं क्यों आज आप, your camera is also off, you're not replying. क्या तबीयत ठीक नहीं है आपने कहा ना? What happened?
No, sir. I'm just not feeling well today, sir. Been sick for a few days.
अच्छा, you're recovering. तबीयत मतलब आपको बस ठीक नहीं लग रही है. Okay. So you will write now types of SN. SN1, SN2. This is unimolecular nucleophilic substitution. And this is bimolecular nucleophilic substitution. Okay. We'll be looking at details of SN1 and then SN2. After this, you will write the heading SN1. So what is SN1 reaction? The reaction in which, please write with me, rate depends on concentration of substrate only. Substrate means haloalkane. Only is called SN1. The rate will be equal to the rate constant K multiplied by the concentration of haloalkane. Right. So here the order of reaction: 1, and molecularity is also equal to 1. ठीक है. After this, we are going to look at the mechanism. ठीक है, mechanism भी काफी important है. Please write the heading. Mechanism. First thing that we should remember, it occurs in two steps. It occurs in two steps. The first step is breaking of CX bond or formation of कार्बोकेटाइन. फॉर्मेशन ऑफ कार्बोकेटाइन. ठीक है. नाउ प्लीज ध्यान से देखिएगा, डोंट हैव टू राइट एनीथिंग राइट नाउ. कार्बन एंड देयर आर थ्री ग्रुप्स हियर, 1 2 3. कोई भी तीन ग्रुप यहाँ पे अटैच्ड है, एंड देयर इज वन group that is halogen in which we are most interested. So what would happen in the first step, breaking of CX bond? We can say that this sigma bond can break like this. And obviously this step will be very slow, and that will be also somewhat reversible, not completely, but somewhat reversible. And this step, I can say that it is going to be quite slow step. And as soon as the X leaves as X negative, we will get a carbocation. And carbocation will be like this. So here you will have the 1, 2, and 3. Plus we will have the X negative. Plus we will have the X negative. Now this is a carbocation. This is a carbocation. First step. In the second step, what would be happening? The second step would be the attack of nucleophile. Attack of nucleophile, or we can say that formation of attack of nucleophile, or the formation of carbon and nucleophile bond. ठीक है, carbon nucleophile bond. This is more important, है ना? This is more important. Now, if you look at the carbocation that we are having, na, this is my carbocation. यहाँ पे थोड़ा सा आपको information, like there will be slight knowledge of the 11th standard which will be used, but ज़्यादा नहीं. ठीक है, ध्यान से सुनिए जरा. This is carbocation. Don't have to write this down, just try to understand. Carbon, it has the atomic number of what? 6. The electronic configuration will be 1s2, 2s2, and 2p2. Now from the carbon, if I look at the valence shell, I have 2s and then I have 2p. This will somewhat give you an idea about 11th standard. थोड़ा सा याद आएगा शायद. 1 2 electron, 1 electron, 2 electron, like this. Now we know that promotion of electron would take place like this, and the hybridization of sp, you will get some hybridization like this. You will have, अच्छा, carbon 6, but we are having a carbon positive ना, तो positive है तो यहाँ पे एक इलेक्ट्रॉन कम होगा. So it will be 2p1 rather, not 2p2. We'll remove one electron now, so it will be 2p1. One electron will not be there. Now one of the electron, it will jump and get excited to this part, and you will have s with one electron and the p with 2 electron occupied like this. Now these three half-filled orbitals will make hybridization. It is made up of 1s and 2p orbitals. So all of these are what? sp2 hybrid orbital. And then there will be pure p orbital which will be vacant. All of these are having one electron, and this is pure p orbital, which is pure p, having a shape of double like this, and it is what? It is going to be vacant. And since it is vacant, we are having a positive charge. So this is the important part that we have to remember from the 11th standard. ठीक है, तो ध्यान से देखिए यहाँ पे, इसको मिटाते हैं, and I am going to put the p orbital like this. ठीक है, so we have the p orbital. हम ध्यान सुनिए जरा. When the nucleophile will come, na, it will attack the carbon atom, but it will, देखिए कार्बन एटम पे तो अटैक करेगा to give the electrons, है ना, to give the electrons. Now nucleophile, it is what, it's a lone pair, right? It is having a lone pair and a negative charge maybe, ठीक है, and a negative charge maybe. Now what it is going to do, it is going to attack the carbon atom. So carbon पे it is going to attack, that means it is going to give electrons to carbon. Now where it is going to give the electrons to the carbon atom? Electrons की जगह जो होती है, that is orbital. So it will give electron to a certain orbital of carbon atom, and that certain orbital is the pure p, which is vacant. Does this make sense, Arsalan, Krishna Priya, and me? Yes or no? Please tell me quickly.
Yes, sir.
What's okay? Now please understand that the p orbital, it is having two different lobes. So there is 50-50% chances, right? There's a 50% chance that this nucleophile, it is going to give the electron on this lobe. And there is also a 50% chance that this nucleophile is going to give electron on this lobe. अब आपको लगेगा सर ये रेड वाला होगा ना, नजदीक है, बट प्लीज ट्राई टू अंडरस्टैंड वी आर डीलिंग विद द सॉल्वेंट इन लिक्विड स्टेट, है ना, दो कार्बन, एक कार्बोकेटायन एंड देयर इज वन न्यूक्लियोफाइल, ऐसा केस नहीं है, रैंडमली एवरीथिंग इज मूविंग. सो दैट इज व्हाई वी हैव टू टेक द 50-50% चांसेस. नाउ इफ आई गो थ्रू द ग्रीन रूट, please see here guys, if I am going towards the through the green route, then what is going to happen? If I am going through the green route, you can see that nucleophile will be attacking, like it is going to attach from the behind like this. We'll have nucleophile which is attached to carbon atom like this, and this carbon will be attached with three different groups as earlier, but here we'll be having 1, 2 and 3. Then another case would be the red one. If I am going through the red wala route, if I am going through the red mechanism, the red attack, then you can see that we are going to make a compound which is like this: the carbon atom, first group, second group, the third group, and the nucleophile will be attached here. Now I want you to compare these product with the original structure. If you look at the original structure, if you look at the original structure and look at the green product, you can see that it is completely ulta, na, inverted. So that is why you get 50% inverted product. This process is known as inversion. यहाँ पे लिख देते हैं inversion, and this product will be known as, and the quantity that we will be making is 50%, because 50% chance है ना, there are two lobes, 50% from the front or 50% from the back. It is 50%, and this is known as inverted. And if you look at this red product, the red product is having the configuration completely as it is the original one. जहाँ पे halogen था, where there we are having nucleophile, the first, second, and the third carbon are there, are in their places. There is no change. So this is known as retention. The process is known as retention. And we say, and again, the quantity will be 50%, and it will be retained. Or we also call this retention product. Retained product, but retention product is more common. Retention product. Now tell me guys, does this make sense? Yes or no? Please tell me. Krishna Priya, Arsalan, and Mir. Inversion and retention, does this make sense?
Yes, sir.
Arsalan and Mir, tell me guys.
Yes, sir.
Okay, fine. So please now write this down. Raise your hand once you're done. I think you have to write from the mechanism. Then we will write these points. थोड़ा सा कुछ note में लिख लेंगे हम लोग. Write this down. Raise your hand once you're done, and you will draw it as it is. कुछ छोड़िएगा मत यहाँ पे, है ना. Okay. Now, there are a few points that we will write here. The first point that you have to memorize this point, As soon as you think of SN1, you should be thinking of a few things. The first thing that you should be thinking of is the carbocation. So SN1 occurs via carbocation. Intermediate is one of the reactive intermediates. What it is carbocation. Since stability of carbocation is that 1 degree is most, sorry, my bad guys. 1 degree is least stable, then 2 degree, and then 3 degree. The rate of SN1, if I talk about, this is generic, detail we are going to look, but generic rate of SN1, 1 degree is slowest, then followed by 2 degree, and then followed by 3 degree. And also rate, it is directly proportional to stability of carbocation. Next is, and now this is regarding the first step that is happening, right? The slowest step. If we can fasten the slowest step, the speed will increase. That is why the rate is directly proportional to the stability of carbocation. The more stable carbocation is present, the halogen, the leaving group will leave fastly. If it is leaving fastly, obviously the complete reaction will be fast. Next point is regarding the next step. You'll write, since nucleophile attacks on vacant p orbital of carbocation, it can attack, whether I can say it attacks 50%, 50%, it attacks 50% on one lobe and 50% on the other. Resulting in, you can say, resulting in 50% and 50% retention. Okay. In the mixture that we are going to get, now see, both of these 50% inversion and retention, this will be happening. This reaction will be happening in one container, and the container will contain 50% inverted product, 50% retention product. Now, this mixture of 50% inverted and 50% retention product, it is known as the racemic mixture. And the process is known as racemization. Please write. The mixture containing 50% inverted product and 50% retention product is called racemic mixture, and the process is called racemization. Okay, please write this down. Raise your hand once you're done. Okay, all of you guys are done. ठीक. अब SN2 भी कंप्लीट कर लेते हैं, then we will end the class. Okay. Please write the heading. Sorry, guys. SN2. In this reaction, as the previous reaction, the rate depends on one of the molecule, that is substrate. Here the rate depends both on the substrate and the nucleophile. Okay. So please write rate depends on both substrate and nucleophile. So if I talk about the rate equation, it will be equal to the rate constant multiplied by the substrate and nucleophile. Okay. Order will be 2 and molecularity is also 2. Now let us look at the mechanism. Now the mechanism, only you have to remember only one thing, that it occurs in single step. It occurs in single step. It occurs in single step. Okay. So we have carbon. ध्यान से देखिएगा फिर से ना. You have to just see once again. First, second, and third group. Okay, please don't write it now. ध्यान से देख लीजिए, उसके बाद हम लोग इस बात पे फिर, I mean, then you can write it down. Now, this halogen atom is there. So this halogen will be obviously delta negative because it is what? More electronegative element. And then we have our nucleophile. Okay. So nucleophile with a lone pair and negative charge. So एक चीज आपको समझ में आनी चाहिए, that this nucleophile cannot attack the carbon from the front. Why? Can you see that if it is going to attack from the front, the negative charge of nucleophile and the halogen, it is also having negative charge. Also halogen, it has 3 lone pairs. Please remember that also. Halogen जो होता है ना, इसके पास 3 lone pair होते हैं. It has 7 electrons. 1 electron is bonding. It is busy in bonding, and there are 6 electrons which are lone, which are not in bonding. They are non-bonding electrons. All the non-bonding electrons act as lone pairs. 6 electrons, that means 3 lone pairs. So you can completely see that there will be electronic repulsion. Yes or no? Please tell me, guys.
Yes, sir.
Can you see electronic
Yes, sir.
repulsion if the nucleophile will attack from the front? So ध्यान से देखिएगा. So if the nucleophile is going to attack from the front, it will be very difficult. Then it is going to attack from the behind. But you will say, sir, behind spacey kahan hai? Bilkul spacey nahi. You will say, yeah, that is only because we have not shown the space. But if you know the tetrahedral structure, you know that one of these bonds will be what? Behind the plane. And one of these bonds will be what? Outside the plane. So if you see, one is behind the plane, one is outside the plane, and one is on the plane. So you can see there is a cone type of structure, ना? ऐसा cone type का दिख रहा है आपको? 3D में अगर समझे तो, if I take all of these bonds behind the plane, on the plane, and outside the plane, can you see a cone type of structure? अब इसी के बीच में nucleophile आ जाता है. Does this make sense? Tell me, guys. Yes.
Yes,
Do I
sir.
need to show you actually? I can show you. Just give me a second. I will show it to you guys. Just give me a second. How the nucleophile is going to attack, no? Can you guys see this molecule?
Yes, sir.
Okay, so this is the bromine. The red one is bromine, है ना? And can you see this part? यहाँ पे अटैक हो सकता है ना? देखिए, this is like a cone ना? ये cone जैसा दिख रहा है आप लोग को? Attack from behind, and it can then attack on the carbon atom. Can you guys see that? Arslan, Krishna Priya, Mir?
Yes, sir.
Yes, sir.
है ना? So when this attack happens, then this bromine atom will leave, and then it will not leave directly. but rather what is going to happen, you will have carbon and the hydrogens will be as like this. There will be bond breaking between carbon and bromine like this. Carbon and bromine are breaking with the bond, and there is a formation of bond between carbon and nucleophile like this. Okay, so dashed line, I can see that it is bond formation and BR is bond breaking. So here 1, 2, 3 are as it is. Now this particular state, it is known as transition state because it is going from CBr bond to C nucleophile. So there is a transition happening. So this is known as transition state. Okay, so the most important point that you have to understand here in the nucleophilic substitution reaction bimolecular SN2 is that the nucleophile attacks from the backside. Backside attack occurs, only backside attack occurs. Okay. Now we are going to back to the OneNote. Okay. Since you understood this part. So what we understood is that nucleophile is going to attack from the behind. We'll erase this. And the nucleophile, it is going to attack from the behind like this. And the halogen atom will leave as leaving group. And we will get carbon. Say 1, 2, 3. And here I can show red with Br since it is breaking, and nucleophile blue since this bond is forming. Okay. And this whole thing, it is known as transition state. Just make the square bracket. Transition states are given in square brackets always. Okay. So the color. Now, next, what happens? You have carbon, nucleophile bond, and then you have 1, 2, 3 plus X negative. Oh, Br हमने लिख दिया. Guys, can you please change this to X because we are taking a generic case X negative. And as you can see, it is 100% inverted product. Inverted product. Okay, so the most important part is SN2 occurs via transition state. And we can say nucleophile attacks from the backside leading to inversion of configuration and formation of 100% inverted product. Write this down. Raise your hand once you're done.